Imagine looking up at the night sky and realizing most of what you see is already gone. Galaxies once brilliant and near are now rushing away so fast that their light will never reach us again. Not because they exploded, not because something destroyed them, but because the very fabric of space is stretching so rapidly that it's erasing them from our reality. This isn't science fiction. It's the fate of the universe unfolding right now. And the scariest part, we're among the last beings who will ever see the cosmos in all its glory. Chapter 1. Space itself is expanding faster than light. We often imagine galaxies drifting apart like debris from a great explosion. That's the classic image, the Big Bang as a colossal blast, flinging matter into all directions. But that picture is misleading. The truth is more subtle and far stranger. Galaxies aren't flying through space like rockets. Instead, it's space itself, the very fabric of the universe that's expanding, and it's doing so in every direction, all at once. Imagine drawing dots on the surface of a balloon. As the balloon inflates, the dots move farther apart, not because they're moving on their own, but because the surface they sit on is stretching. That's what our universe is doing. Space is stretching, and everything inside it, galaxies, clusters. The cosmic web gets carried along with it, passively drifting as the distances between them grow. What makes this truly eerie is the role of distance. The farther away a galaxy is, the faster it appears to recede from us. This isn't an illusion. It's built into the mathematics of cosmic expansion. There's a threshold, a distance, beyond which galaxies aren't just far away. They're unreachable. Their light, traveling at the fastest speed allowed by the universe, can no longer catch up with the space that's expanding between us. That threshold is called the cosmic horizon, and with each passing moment, more and more of the universe is slipping past it. Not because it's moving faster than light, but because the space between us is growing so rapidly that no signal, no matter how fast, can bridge the gap. Light from those galaxies stretches into longer and longer wavelengths, redder, colder, dimmer, until it fades completely. Eventually, it stops arriving altogether. This isn't science fiction. It's already happening. Every second, countless galaxies pass beyond the limits of what we can ever observe. We are losing them not to destruction, but to separation. The universe is expanding faster than light can keep up, and this expansion isn't slowing down. It's accelerating. That means the rate at which galaxies disappear from our view is increasing. In the future, only the nearest galaxies will remain visible. Eventually, even they will fade, and we will be left with nothing but darkness. This reality changes everything we thought we knew about distance and time. In our everyday lives, distance is a fixed concept. A kilometer is a kilometer. But on cosmic scales, space is dynamic. It grows. And when it grows faster than light can travel, it creates a barrier more absolute than any wall. Think about that. There are parts of the universe, vast regions filled with stars, planets, perhaps even life, that are already beyond reach. We will never see them, never know them. Their light left billions of years ago, but it will never arrive. They are as good as erased. And that's not just true for us. Any intelligent civilization, anywhere in the universe, faces the same boundaries. No matter their technology, no matter how advanced, they are trapped within their own observable bubble. Cosmic isolation is universal. This wasn't always the case. In the early universe, things were closer together. Light could travel more freely, but as space stretched, It carried galaxies away from each other gradually, inexorably, until they vanished beyond the horizon. Even now, the light we see from distant galaxies isn't what they look like today. It's what they looked like billions of years ago. Some of them may not even exist anymore. What we observe is a memory, a snapshot frozen in time, carried across an ocean of expanding space. So what does it mean to live in a universe like this? It means the sky is a story written in past tense. It means we are observers standing on a shrinking island of visibility, watching the cosmos retreat in every direction. And no matter how fast we chase it, we will never catch up. This phenomenon isn't just a curiosity. It's a fundamental property of the universe, driven by something we don't fully understand: dark energy. This mysterious force is responsible for the accelerating expansion. It makes up nearly 70% of the universe, yet we have no idea what it is. What we do know is this: dark energy is pushing the cosmos apart at an ever faster pace, and as it does, the observable universe becomes smaller and lonelier. One by one, galaxies vanish from view, not into black holes or fires, but into silence. Cosmic silence. You might ask, can anything travel faster than light? The answer, surprisingly, is yes, if it's space itself. Space isn't made of matter. It has no mass. It isn't limited by the rules that govern particles and photons, so it can expand as fast as it wants. And right now, in the most distant regions of the universe, it's doing exactly that. This changes our understanding of limits. In school, we learn about the speed of light as an ultimate boundary. Nothing can outrun it. But in the cosmic race, light is falling behind. Expansion is winning. Entire galaxies are disappearing, quietly, forever. Even more haunting is what this means for the future. Every second we wait, more of the universe becomes permanently inaccessible. Our window into the cosmos is closing, not because of clouds or fog or dust, but because of the nature of reality itself, and no one can stop it. In this light, the present becomes precious. We live in a narrow slice of time where the universe is still visible, still bright, still filled with wonder. But that window is finite. Someday the stars will go out, the galaxies will vanish, and the night sky will become a mirror reflecting only our own loneliness. We are lucky and we are cursed. Lucky to witness the cosmos in its prime. Cursed to know it won't last, because space isn't static, it grows. And with every heartbeat, the edge of the observable universe moves closer. Not because we're reaching for it, but because it's pulling away. And one day, we'll look out and see nothing. Chapter 2. The observable universe is shrinking. The observable universe is everything we can still see. It's a cosmic bubble stretching across 93 billion light-years, filled with galaxies, stars, nebulae, and light that has traveled billions of years to reach us. But this view is not permanent. It's not stable. In fact, it's shrinking not in size, but in accessibility. Every year, more and more of the cosmos slips beyond the limits of what we can ever observe. Beyond a certain distance, roughly 46.5 billion light-years away, galaxies are moving away faster than light can ever catch up. Not because they're accelerating through space, but because the space between us is expanding at such a rate that even a beam of light emitted right now will never reach us. That light is lost, not because it's too faint, but because the space it must cross is stretching too quickly. This isn't just a theoretical problem. It's a reality unfolding right now, in real time. Galaxies that are visible today will one day disappear not by burning out, but by becoming unobservable. We are witnessing an ongoing erasure, a quiet vanishing of cosmic history. Imagine standing in a field with a lantern. Everything within the reach of your light is visible, but anything beyond remains in darkness. Now imagine the field itself growing faster than your light can travel. Slowly, steadily, the edges of your visibility move inward. The darkness increases. One by one, the landmarks you once saw vanish beyond your light's reach. That's our universe. That's what's happening to the stars. No telescope can change this. No future civilization, no matter how advanced, can build a machine fast enough to catch up with that retreating edge. There are galaxies out there, full of stars and planets and perhaps life, that we will never know existed. Their light is already too far gone. This cosmic horizon defines the ultimate boundary of our awareness. It's not an edge made of walls or particles, it's made of time and expansion. And with every tick of the clock, more of the universe moves beyond it. To put this in perspective, the light we see from the most distant galaxies began its journey over 13 billion years ago, but those galaxies are now more than 30 billion light-years away. Why? Because space has been expanding during the time their light has been traveling. They are no longer where we see them. They've moved far beyond, and some have already crossed the point of no return. Their last photons are already en route, but nothing they emit from now on will ever reach us. The observable universe isn't defined by what exists. It's defined by what can still reach us, and that makes it temporary. This shrinking visibility has strange consequences. The night sky we see today is not a map of the present. It's a deep archive of the past. The farther we look, the older the light. When we observe a galaxy 10 billion light-years away, we're seeing it as it was 10 billion years ago. But many of these galaxies have moved beyond our reach since then. We're staring into ancient shadows, ghosts of structures we'll never witness, evolve, or die. They're already gone, in practical terms, and we are simply waiting for their last whispers of light to fade. This is not just about stars. It's about knowledge, about what can be known. As our cosmic bubble shrinks, so does the total sum of what any being in the universe can ever learn about the cosmos. We're entering an era where the deeper truths of existence may lie forever beyond observation. No experiment, no observation, no journey will ever cross that limit. We're approaching a horizon not of geography, but of truth. And the universe is doing this silently. There is no alarm, no visual cue. Galaxies fade so gradually, redshifted into invisibility, that we don't even notice as they disappear. It's like losing someone in a dream. One moment they're there, and the next, gone without explanation. Every year, thousands of galaxies vanish this way. Our glowing sphere of visibility shrinks inward, as though a curtain of darkness is falling across the stars. We are trapped in a prison of light, a glowing sphere surrounded by an ocean of unreachable space. And even this prison is growing dim, in billions of years. The only galaxies left visible will be those gravitationally bound to our own, like the Andromeda Galaxy and a few nearby companions. Everything else will have slipped beyond the horizon. The sky will become emptier, colder, and quieter. To future civilizations, the universe will appear much smaller. They may believe the cosmos is limited, or that their galaxy is alone. without evidence of other galaxies. The idea of a vast expanding universe might seem absurd. Cosmology itself may fade from science into myth, unless we record and preserve what we know now. The truth of our place in the cosmos could be forgotten. That's why this moment, this tiny slice of cosmic history, is so special. We live at a time when the universe is still visible, when the great web of galaxies still shines across the sky. We are privileged to witness it, but that privilege is temporary. We are the last generation standing on the shores of the observable ocean, watching the tide pull away the stars, and what remains is more than just beauty. It's data, clues, the faint fingerprints of what came before. The shrinking, observable universe isn't just a loss of scenery. It's a loss of memory. Every galaxy that disappears takes with it a chapter of the universe's story, locked behind a wall we can never pass. We are, quite literally, watching reality disappear. This isn't cause for panic. It's cause for reflection, for wonder, for appreciation, because we still have time. We can still see, still learn, still ask the big questions. And we can tell stories about what we've seen before the curtain falls. So the next time you look up at the stars, remember the light reaching. Your eyes is a message from a world that may already be gone. You are witnessing something ancient, something fragile, something fleeting, and you are among the last who ever will. Chapter 3: The Coming Silence. Now imagine a time so far in the future that the numbers begin to lose meaning. Trillions of years from now, the universe will look nothing like it does today. The grand spiral arms of galaxies will be gone. The brilliant tapestry of stars will have faded. There will be no glowing nebulae, no supernova lighting up the void. The night sky, once filled with wonder, will be empty. Humanity, if it still exists, will look up and see nothing but darkness. The galaxies that once painted the heavens will have long since vanished beyond the cosmic horizon. Their light will no longer reach us. Even the nearest galaxies, once visible to the naked eye, will be gone. The universe will be silent. In this far future, the stars of the Milky Way will have burned out one by one. The youngest and brightest stars will have exhausted their fuel. Red dwarfs, the longest living stars, will finally go dark. Their dim embers will fade into cold cinders. What remains are the corpses of stars, white dwarfs, neutron stars, and black holes. No new stars will be born. The cosmic engines that once turned clouds of hydrogen into brilliant suns will have shut down. Star formation will have ended. Without stars, there is no light. Without light, there is no warmth. The galaxy will become a graveyard, silent and cold. Planets will remain, orbiting the remains of their dead stars, but they will be frozen, lifeless worlds. The faint afterglow of the Big Bang, now stretched into radio waves by cosmic expansion, will be nearly undetectable. The background hum of creation will be lost in the silence. There will be no more stories written in starlight, no more new elements forged in stellar cores, no more supernova to scatter the ingredients of life across space. The cosmos will become static, unchanging, and dark. A void where time still passes, but nothing happens. And perhaps the most haunting part is this: silence doesn't arrive all at once. It creeps in slowly. First, the farthest galaxies fade, then the nearby ones. Then the stars of our own galaxy begin to disappear, one by one, like candles going out in a vast cathedral. Eventually, only the black holes will remain, Black holes do not shine, but they dominate. Their gravity shapes the orbits of stars and planets. They are the last giants standing in a universe gone dim, but even they are not eternal. Over unimaginable spans of time, black holes will begin to leak energy through Hawking radiation. It's a process so slow that it makes the lifespan of stars look like the blink of an eye, but it happens. Bit by bit, black holes will evaporate, shrinking until they vanish in a final burst of radiation too faint for anyone to notice. And then there will be nothing. No light, no sound, no structure. The atoms that once formed stars, planets, oceans, and living beings will drift endlessly through space, separated by such vast distances that interaction becomes impossible. It is the quietest possible state of existence. Entropy, the great equalizer, will have claimed everything. This era, the black dwarf era, the dark era, is not a possibility. It is a mathematical certainty based on our current understanding of physics. The universe is not dying in fire, but in cold. A slow fade into stillness. A cosmic whisper that becomes a breath, and then nothing at all. If consciousness still exists at this point, it will be surrounded by silence. It will have no sky to gaze upon, no stars to guide it, no cosmic neighbors to ponder. There will be no mysteries left, because there will be nothing left to explore. The past will be gone, and the future will hold no promise. Just a long, endless now. And yet, this silence carries weight. It is the silence of a life well lived. The universe was not always dark. It was once full of sound and color and motion. It birthed galaxies, stars, and life. It told stories through gravity and light. And maybe, just maybe, we were part of one of those stories. For a brief moment, we looked out and saw everything. We studied the stars, wondered about our place in the cosmos, and tried to understand the nature of existence. We captured the light of galaxies that no longer exist. We listened to the echoes of the Big Bang. We reached out, curious despite the cold. In that sense, the silence that follows is not just an ending, it's a memorial, a vast, eternal record of what once was. The universe doesn't remember in the way humans do, but every particle, every wave, every subtle shift in energy is a trace of history, a fingerprint of moments that can never be repeated. This coming silence will not arrive with a bang or a flash. It will unfold slowly, gently, like a song fading out. At first, we may not notice. The stars will still shine, but as time stretches, the changes will become undeniable. The galaxies will thin out, the night sky will dim, and eventually everything will go quiet. What does it mean to live in a universe destined for silence? It means that time is precious, that light is rare, that wonder is fleeting. We are the lucky ones. We live in an age when the universe is still alive, still speaking, still visible. We are surrounded by beauty that future civilizations may never know existed. To them, the universe will be dark, and the stories we tell about stars and galaxies will sound like myths. But they will be true. Every star that ever burned left a mark. Every beam of light that ever traveled across the cosmos carried a message. And for a brief, shining window of time, we were here to receive them. One day, the last light will fade. The final echo will fade into the void. The curtain will fall on the greatest performance in history, the unfolding of the universe, and the silence that follows will not be empty. It will be full of memory. a quiet testament to everything that ever was. We will not be here to see that silence, but we can imagine it. We can feel the weight of it in the stillness between the stars. And in that stillness, there is meaning, because silence too is part of the story. Chapter 4: Hawking Radiation and the Final Fade. Black holes are often thought of as eternal, immense voids that swallow everything and give nothing back. For decades, they were seen as the final graveyards of matter, a place where the rules of physics break down, and from which not even light can escape. But that understanding changed with a single idea. In 1974, Stephen Hawking proposed something radical. Black holes aren't perfectly black. They emit radiation, not from their surface, but from the strange quantum fluctuations that occur right at the edge of their event horizon. This phenomenon, now known as Hawking radiation, changed our understanding of black holes and the fate of the universe itself. According to quantum mechanics, empty space is never truly empty. It teems with virtual particles, constantly flickering into and out of existence. Usually, these particles annihilate each other instantly, but near the intense gravity of a black hole's event horizon, something different can happen. If a pair of particles forms just at the edge, one may fall into the black hole while the other escapes. To an outside observer, it looks like the black hole is radiating energy, slowly, relentlessly, over time. This process causes the black hole to lose mass. The larger the black hole, the slower the radiation. But eventually, even the most massive black holes will shrink, evaporate, and vanish completely. This evaporation takes an incredibly long time. A black hole with the mass of our Sun would take 10 years to disappear. Supermassive black holes at the centers of galaxies will last even longer, up to 10 years or more. But time, in a dead universe, is infinite. There's no rush. The stars have burned out. The galaxies have faded. All that remains are black holes, slowly radiating away their last energy into the void. And when the final black hole evaporates, what's left is not darkness. It's something even more profound. Stillness. No structure. No thermodynamic gradients. No usable energy. Just a cold, thin mist of subatomic particles, photons, electrons, neutrinos drifting through endless space. Nothing collides. Nothing clumps. Nothing changes. This is the heat death of the universe. Despite its name, the heat death isn't hot. It's the opposite. It's the result of entropy reaching its maximum value. Entropy is a measure of disorder, a way to describe how spread out energy is. In the heat death scenario, all energy is evenly distributed. No more stars, no planets, no black holes. No organized motion, just particles moving aimlessly in a sea of absolute cold. In this final state, time continues, but meaning fades. With no change, time becomes irrelevant. Without events, there's no past or future, just an eternal present. The universe won't collapse. It won't explode. It will simply exist in the lowest energy state possible, forever. This outcome is one of the most widely accepted among physicists. It is the logical conclusion of the second law of thermodynamics. Everything tends toward equilibrium. And in a universe with no more sources of usable energy, equilibrium means stillness, silence. And yet, in this cold emptiness, there is a kind of strange beauty. The universe, after all its chaos and brilliance, will end not in violence, but in peace. It will fade, not fall. There will be no last flash, no final scream, just a gradual dissolving of structure into simplicity. A soft landing after an eternity of turbulence. Even the particles that remain may not be truly stable. Some theories suggest that protons, the building blocks of atoms, could decay over unimaginable spans of time, 10 years or more. If that's true, then even the last atoms will disintegrate, leaving behind only radiation. At that point, not a single atom of matter would remain. Only energy, dispersed evenly across a vast, empty cosmos. This is the last phase of the universe. No rebirth, no reset, just a long, quiet fade. It's hard to imagine anything more final. And yet, some physicists speculate that even in this emptiness, strange things might still occur. Quantum fluctuations could, in theory, trigger new events, perhaps even birth a new universe. But these are distant possibilities, far beyond our capacity to witness or influence. From our perspective, the most haunting truth is that the universe doesn't end with a bang. It ends with a whisper, a gradual slipping into oblivion. And as we learn more about the nature of space, time, and entropy, it becomes harder to avoid that conclusion. The universe is not infinite in opportunity. It is finite in its ability to sustain structure, energy, and life. We are lucky to live at a time when the cosmos is still full of wonder, when galaxies still shine, when stars are still born, when light still travels freely. We are surrounded by energy, by motion, by meaning. But that's not the natural state of the universe. It's just a temporary chapter, a flash of order in a sea that will, eventually, dissolve into randomness. The journey from the Big Bang to the heat death is a story of transformation. From singularity to structure, from fire to stars, from galaxies to life, and finally, to silence. Each phase had its moment. Each left its mark. And now, with Hawking radiation, we understand the last act. When the last black hole evaporates, there will be no witnesses. No one left to remember. But that doesn't make the ending less real. It just makes our present more valuable. Because we're here now. We can see, think, feel, and wonder. We can ask where it all came from and where it's all going. And we know now that it ends, not with destruction, but with quiet dispersal, a slow unraveling into the smoothest possible state. A universe where nothing happens because nothing can. No heat to transfer, no stars to ignite, no time to mark. Just a flicker of particles, and then nothing. That final fade is the price of time. It's the cost of entropy. It's the destiny of a universe that began with a bang and must end in silence. And yet, in this silence, there is meaning. Because we, for a brief moment, were here. We saw the stars. We touched the light. We knew the story. And when the last spark goes out, it won't be a tragedy. It will be the final line in a long, beautiful poem written in gravity and light. Here's a chilling thought. We may be living in the brightest moment the universe will ever offer. A fleeting window when the sky is still alive with galaxies, with starlight, with the echoes of creation. We can look up and see the vast structure of the cosmos, filaments of matter stretching across unimaginable distances, stars being born, galaxies colliding, an ancient light arriving after billions of years. We can wonder about the Big Bang. We can ask what came before time began. We can marvel at what might lie beyond our cosmic horizon. But this moment will not last forever. In fact, it may be uniquely brief. There is a time before us when the universe was too young, too dense, too bright to see clearly. And there is a time ahead when it will be too old, too dark, too quiet to see anything at all. We are balanced on a thin edge between those extremes, a moment of clarity between two eternities of blindness. We are one of the few generations, perhaps the only one, to witness the universe in its fullness, to see the stars not only with our eyes, but with our instruments, with our minds, with our questions. This may be the most luminous moment in all of cosmic history, and perhaps, in a strange and solemn way, it is also the loneliest, because the more we learn, the more we realize what's slipping away. Every year, more galaxies vanish from view. Every second, the cosmos grows colder, more distant, more quiet. The silence is coming. It's not loud. It doesn't arrive suddenly. It drifts in like fog, slow, relentless, final. Someday, perhaps not long from now, in cosmic terms, no one will be able to see what we see today. No evidence of the Big Bang, no galaxies beyond the local group, no cosmic microwave background. The universe will appear static, small, and empty. If intelligent life survives into that future, it may never know the truth. The clues will be gone, the story erased, the light forgotten. But we are here now. We still have time. We still have stars. We can still ask the big questions, and we can remember. We can record. We can pass on what we've seen before the last light fades, because one day it will, not with a crash, but with a long, slow fade into absolute stillness. And in that final darkness, the universe will rest not destroyed, but finished. Until then, we watch, we wonder, and we listen to the last whispers of a living cosmos.